Now, we're not, of course, just going to solve equations for the sake of solving equations. The time has come to apply them to story problems. In this segment, we're going to look at two examples. With story problems, there's nothing for it but to do them. So, let's get started. Here is the problem we'll work with. You start with an 8 by 11 inch piece of paper. You are going to cut off a strip of uniform width. That just means it's the same width all the way around. Around the paper. Your new area is 40 square inches. Your task is to find the width of the strip. Now, I wrote this out in a list. I've already done a bunch of interpretation on the original problem just by writing it this way. When you get a story problem, a very useful thing to do is extract information like this. Even if you write out the whole paragraph copied over, circle the thing that you're trying to find. So at the end you can go back and ask yourself the question, did I really find what I was supposed to? I often read problems and people have done just an absolutely beautiful solution of a wonderful problem that was not the question asked. So go back at the end and see if you really answered the right question. It's very easy to get caught up in all the fun math. Our first move here is going to be to draw a picture. A picture paints 1,000 words, and it really is true. What do we have? Well, we have this piece of paper. It's 8 inches long on one side by 11 inches on the other. We're going to cut around a strip and cut it off for reasons unknown. That strip has the width X all the way around. It's a uniform width, and that's what we're trying to find. So we may as well right away call this X. See if I can zoom in a little bit on my beautiful sketch here. Okay. Now, we're also told that the new area is 40. So all of this outside part here is going away. And what we're going to be left with is an area of 40 for this inside piece. We need to come up with some kind of an equation. What do we know? Well, we know we're working with area, and area is length times width. So let's see what we can extract from this picture. Let me go back out a little bit and see if we can write some kind of equation for this. Area is length times width. We know that for the smaller piece, that the length times the width has to be 40. That's what we're given for information. What do we know about the length and the width? Well, our old length was 11. What's our new length going to be? Well, I had 11, and I cut out X. I don't know if you can see that. No, this way. I was going the right way to begin with. And I cut out X. And then on the other end, I cut out x again. So my new length in here was 11 minus x minus x. That's how much physically we cut off. So we can say our new length, L, is equal to 11 minus x minus x. Well, then L is 11 minus 2x. We have just gained some useful information to use with our formula for area. Well, let's do the same thing with the width. Our old width was 8. Again, we cut off x from each end, so our new width, W, is going to be 8 minus 2x. I can now say, instead of having L times W equals 40, I can write an equation with one variable, 11 minus 2x times 8 minus 2x equals 40. I have an equation to solve. And we have all of the tools to do that. Our first move, of course, is to get it equal to 0. So we're going to have to multiply this out. Solve is such a wonderful word. It encompasses many tasks. When we multiply this out and move the 40 over, we're going to end up with, I'll go ahead and write the in-between part. We're going to have 88 minus 16x minus 22x plus 4x squared minus 40 equals 0. We can simplify that somewhat, and we'll end up with 4x squared minus 38x plus 48 equals 0. Now, we're going to look and see if we can factor anything out. Immediately, I know I can get a 2 out because I have all even numbers. And when I do that, I'll be left with 2x squared plus a negative, since I just forgot to write a minus, a 19x, and plus 24 equals 0. But it's just a number out front, so I can divide away the 2. And I'm left with 2x squared minus 19x plus 24 equals 0. I will not write out the product sum table, but I will just say that this factors into x minus 8 times 2x minus 3 equals 0. Setting each factor equal to 0, we have that x could be 8. And we want to stop and begin to ask, even though we haven't done the other side yet, is the answer reasonable? If I cut out a strip 8 inches wide, I've cut out the entire paper. I can't use 8. So I'm going to throw that out. Our original paper was 8 inches wide. 8 inches is too big. So we'll work with the 2x minus 3. 2x minus 3 equals 0. Well, adding 3 to each side. 2x then is equal to 3. Divide by 2. X is equal to 3 halves, which in decimal form is 1.5. Let me slide that up so you can actually see it. 1.5 is a reasonable answer. And so that is the number that we keep. If we go back and look at the original question was find the width of the strip. The answer then is the width of our strip is 1.5 inches. Now, what is it that we actually did in this problem? We laid out the information using a picture, writing down all the numbers, extracting them from the words, And we wrote some equations telling us something about the lengths of the sides, and then we used a formula for area.